Hello everyone. So today's I'm going to start your IPSEC VPN in your Palo Alto Firewall. This is the lab topology for which I'm using. In this lab, basically, if you will see, it's a little bit big lab because I used to use this lab on my troubleshooting classes. So, but in your PCNSE also, I was using the same lab. So I will use this firewall as my head office. I will use this firewall as my branch office, and I will use these in HO inside R1 router as my head office inside LAN, and I will use these two subnets as my branch office inside LAN. And this is my internet service provider, and I will just provide the connectivity from here till here. And we are going to configure IPsec VPN between these two devices. Okay. So before this is the if you don't want to use this lab, what you can just use the basic one. Like that only you just, if you have this part, that is also more than sufficient for doing the IPsec VPN lab. You can also connect directly these two devices, doesn't matter. Okay. Only you need an end-to-end connectivity, that's it. This is the one thing. Now, let me just start your IPsec VPN. So guys, before starting this IPsec VPN, let me just tell you the fundamental of your VPN. So first of all, VPN stand for virtual private network. And what is the main purpose of this VPN? What it allows the secure communication over public network. Public network means over the internet. VPN try to maintain CIA on your data, means confidentiality in your data, integrity in your data, and authenticity in your data. And majorly we have a two type of VPNs, IPsec site-to-site VPN, and we have a remote access VPN. This site-to-site VPN, like your IPsec site-to-site VPN, I am going to cover today. Remote access VPN solution is also known as like SSL VPN, if you heard the name. Or in Palo Alto Firewall, same thing is known as Global Protect. In Cisco, this VPN is known as AnyConnect. This is an example of remote access VPN. Like if we are working from home, we are using some type of remote access VPN to connect with your corporate network, to your office environment. Okay. And when we connect head office network with the branch office network, if like whatever people we are having in this branch, if they wants to do the secure communication with this head office people here, for that we always go with the IPsec VPN, and we will use IPsec site-to-site VPN. This VPN is also known as IPsec LAN-to-LAN VPN. And your IPsec site-to-site VPN allow the secure communication over the untrusted network, because if I'll go here in this topology, if you will see, I have my server one here. Let's suppose this is my firewall one at Delhi location. And let's say I'm using here 10.0.0.0/8. This is the LAN subnet I'm using on my Delhi office. I have a firewall, then this firewall have a connectivity with the internet service provider. Let's suppose this connection I have taken from the Airtel. I have one more firewall on Bangalore location. Let's suppose this is my branch location, like this is my branch one. This is my head office or HQ side, headquarter, and I have some PCs here or some LAN network here. Let's suppose I'm using 20.1.1.0/24 at this particular location. Now, if I want to allow the secure communication between this PC, this LAN network and this LAN network, what I have to do, I have to go with the IPsec site-to-site VPN configuration. I will enable the IPsec site-to-site VPN between this firewall and this firewall. Now what they will do, they will basically create one secure channel. They will create one virtual secure channel, or I can say virtual private network. They will create one virtual channel. Now, through this particular secure channel, if this server or this PC wants to do any communication, their traffic will be going to inside this particular channel. And guys, let's suppose, let me just give you some fundamental details as well. Let's suppose this PC wants to send some data to this server. Let's suppose he's sending one message. And on this message, what? He has just put the password. He has just shared the password of some machines. Let's say password is admin@123. Now this PC will forward this particular password towards firewall. Now firewall just put this particular data into this secure channel. It will reach till this firewall. Now this firewall will receive and it will forward this data further to this server. So guys, now the communication which is happening till here is secure. And till here to here, it is unsecure. Unsecure means data between firewall 1 and firewall 2 go in an encrypted way. Encryption and hashing has been, and data encrypted and hashed between firewall 1 and firewall 2. And here you will see the clear text data. Means this password admin@123, if you will capture the packet here in this server, you will get these details correctly. So means because you know this VPN only provide you the protection between two sites over the untrusted environment, because you know this is your untrusted environment where we have a internet. Internet is the untrusted environment. Okay. And how they will basically secure this particular data. So for securing the data, they use three things. There is a term called CIA. C stands for confidentiality. Confidentiality in your data. I for integrity in your data. And A for authenticity in your data or authentication. Now, how they will basically maintain this particular CIA, these three properties in your data. So what they used to do, when they will send this password, this particular password data over the internet, let's suppose there is a one person, we have a one hacker here. Over the internet, he can basically hack your data easily. There are so many things. There are so many ways. So what you used to do, if we will send this data like that, like whatever data we have created here, we will send that data in same form here. This hacker will get that data easily, right? But if we will just encrypt this data, if we apply the encryption on this data, after encryption, maybe after applying this encryption, maybe this data will change. And after that, this data looks like this as actually. So guys, by looking this data, are you able to guess this is the actual one? No, because it's encrypted, right? So guys, confidentiality in your data, we will maintain with the help of encryption. What you used to do, this encryption will convert your clear text or human readable text into the cipher text. Means now this is your cipher text. By looking this data, no one able to guess this is the actual one. So this confidentiality in your data, we will maintain with the help of encryption. And after that, now let's suppose now this is the data which we are sending in over the secure tunnel, over the internet, right? Now this hacker, what he may can just hack this particular data. Now what he can do with this data? He can remove something from this data, or maybe he will add some data on this. Means he can still able to do the tampering in your data. Means he can able to do the tampering. He can able to tamper your data. Now we need some mechanism. Now we need some mechanism in your IPSEC VPN, so we can also protect from the tampering. And guys, this tampering will take care by the integrity in your data. And this integrity we will achieve with the help of hashing. With the help of hashing, what we used to do, because you know this hash, it's a fixed number. If you will calculate hash, it's always a fixed number like 64-bit, 128-bit, 264-bit, 128-bit, 256-bit, right? It's a fixed number. So what we used to do when you will basically run, so what we will do this on this cipher text, we will run some hashing algorithm and we will get some fixed hash value. Let's suppose we get the hash value here, which is 1xya hash star 9. Let's say this is the hash value which I get. So what I will do when I will put this data over the internet, I will just put this hash value as well here. Along with this data. Now, if this hacker, it will do any type of tampering here on this data. When other end receive this data, because you know, firewall 1 and firewall 2, they used to maintain the same password or same encryption algorithm they are going to use. They are going to use same key, because to encrypt the data, we need some keys. To hash the data, we need some key. Okay, and I am going to cover everything. Okay. Now, if they will use the same key, so what it will do when firewall 1 receive this data, what it will first calculate the hash on this particular data, and it will match this hash value with this value. If both value will match, which means now this firewall 1 will know there is no tampering in your actual data. So that's how we will maintain the integrity in your data with the help of hashing algorithm. Now there's a one more challenge which we will be having, like how firewall 1 and firewall 2, they will make sure they are communicating with the right person. Maybe firewall 1 had sent some data. This data is captured by the hacker. Now maybe hacker, he can redirect this data towards another destination. Then we need some mechanism between both the firewall 1 and firewall 2. So they can validate they are communicating with the right person. And this validation they will do with the help of pre-shared key, or with the help of identity certificate, or with the help of certificates. Because you know this pre-shared key, this is a pre-shared key or pre-shared password. Some type of password we will set here, some type of password we will set here. And if they will have a same password, they will do the same type of calculation, and like that they will validate the authentication. So these are the guys main three challenge which were people faced while exchanging the data between two offices. And all these particular thing has been covered by the IPSEC VPN. Because you know, in old days, what used to happen, if you want to maintain the CIA in your data, what you have to purchase a point-to-point link, or I can say the upgraded version of point-to-point link is your MPLS link. And guys, your MPLS circuit is very, very costly. Maybe you need to pay around 2 lakh per month for a MPLS circuit. But if you want to configure the IPSEC VPN, what you need to do? You just need one public IP here, one public IP here. Like you have to pay 200 INR for one public IP at your head office and 200 INR for this public IP at your branch office. And after that, you just need to purchase a internet connection. Internet connection is also very cheap, right? Everyone know. In India, we can get that internet connection like 1 Mbps type of connection, like, sorry, 1 Gbps type of connection in 2000 INR or 3000 INR, right? So now you can think about, if we are using IPSEC VPN, when we are paying 2 lakh of amount per month, now we are just paying 5,000 per month. So guys, that was the biggest reason this IPSEC VPN is adopted by the organizations a lot. And nowadays, everyone is using IPSEC VPN for the communication purpose over the public internet. In every organization, you will see this IPSEC VPN setup everywhere. So this is just a basics about your IPSEC VPN. IPSEC site-to-site VPN required CIA, confidentiality in your data, we will maintain with the help of encryption. Integrity, we will maintain with the help of hashing. Authentication, we will maintain with the help of preset key or either with the help of public key infrastructure, which is your certificates. It will also provide anti-replay protection. So you guys, your IPSEC VPN will also have a inbuilt protection for anti-replay attack. Encryption, what encryption is used to do? It will convert the plain text into the cipher text by using the key. Means in encryption, what we are doing, we are converting your plain text information or human readable data into the cipher text. And decryption, we will use to convert your cipher text into the plain text using the key. And for that, for encryption and for decryption, we need a key, guys. Without having the key and algorithm, we cannot able to encrypt. Anti-replay attack is just a DDoS type of attack, Oscar, okay? If someone is trying to replay the same packets, okay? So when I will cover your exchange part, how they are trying to exchange the messages, that time I'll tell you on that, okay? Now let's try to understand the symmetric encryption. This symmetric encryption, so guys, in encryption, we have a two type of algorithm, symmetric and asymmetric. These are the basic cryptology terminologies, guys. Just remember. In symmetric encryption, these are the some example of your symmetric encryption algorithm: DES, 3DES, AES, 128, 192, 256, and RC4. These are the some symmetric algorithm. In symmetric algorithm, we will use same key for encryption purpose and same key for the decryption purpose. Symmetric encryption is a block cipher. Block cipher means, let's suppose we are getting huge data from your application layer. So what it will basically make a block of that data. And on these blocks, they will basically apply the encryption. DES and 3DES block of data. For example, 64-bit block, AES same data block, whatever the size. So if we will use AES 256-bit algorithm, then it will create a 256-bit of block, and on that block they will apply the encryption. We have a RC4 as well. So generally this encryption, we have a two types. We can use block cipher or we can use stream cipher. Stream cipher means it's a bit by bit encryption. Whatever, like on every bit, they will apply the encryption. Like we have these type of bits, right? They will apply the encryption bit by bit. This is your stream cipher. Now we have a asymmetric encryption. So like your RSA or Diffie-Hellman exchange, DH. This is the example of asymmetric encryption. In this, both sides have two keys. One key is your public key and another one is private key. They will share the public key with other side. And guys, because you know in asymmetric algorithm, we have a two keys, public key and private key. Public key, let's suppose K1 and private key, let's suppose K2. Now, whatever data we will encrypt by using K1, we are only able to decrypt with the help of K2. And whatever data we will encrypt with the help of K2, we will only able to decrypt with the help of K1. And guys, your entire certificate stuff is based on asymmetric algorithm. Whatever data you will encrypt with private key, you are only able to decrypt it by using the public key. And same thing apply in other way as well, like vice versa. There is a one drawback in your encryption. It will not able to provide you the integrity. Means there is no integrity. Means it will not protect us from the tampering of the data. So for integrity, we will use hashing. And there are some hashing algorithm like MD5. It will create a 128 bit of hash. And we have a SHA. It will create a 160 bit of hash. And integrity is a one-way process. Or reverse engineering is not possible in case of integrity. Reverse engineering is not possible. Device create the hash and append it on the header and send it towards the remote peer. Now device authentication, for that we will use HMAC. Preset key used for HMAC. In case of HMAC, both device includes the preset key to run the hashing algorithm. Okay. So they will basically maintain this particular, just give me 1 second. So they will maintain this device authentication with the help of preset key or with the help of certificate. What is anti-replay? A replay attack occurs when an unauthorized user captures the network traffic and then sends the communication to its original destination. Means it is trying to replay the same packets. It will capture the packet and same packet will send multiple times. It's the kind of DDoS attack. Acting as a original sender. To prevent the replay attacks, you can implement timestamps or sequence number. And this particular feature is by default available in your IPSEC VPN. IPSEC sequence numbers are maintained for detecting the replay attack. In IPSEC, it maintains the sequence number. IPSEC window is needed to deal with out of sequence packets. So sometime if we are getting like out of sequence packet, let's suppose instead of packet 1, we have received the packet number 2 first. So there is a IPSEC window is also available, window size, then it will maintain the out of sequence packet. Okay. So guys, your IPSEC site-to-site VPN, it has two phases. We have a phase 0 and we have a phase 1 and we have a phase 2. In IPSEC site-to-site VPN, phase 1 is known as ISACM phase and phase 2 is known as your IPSEC phase. In phase 1, we have a main mode and either we have an aggressive mode. And this is also known as control connection establishment. So guys, generally this phase 1 is known as ISACM exchange. And we will use here, most of the time we are using main mode. In main mode, they exchange 6 messages. This phase 1 we can also run using the aggressive mode as well. But in aggressive mode, we only have 3 messages. The main difference between main mode and aggressive mode, this aggressive mode is faster. We have a less packet exchange, but it is not secure. It is an unsecure. And main mode is a secure one. In phase 2, we have a 3 messages, which is also known as quick mode. This mode is also known as like tunnel mode or transport mode. So in phase 2, we have 2 modes. Either we can run tunnel mode or transport mode. So guys, if when you are using DMVPN type of configuration, when you want to exchange the multicast traffic, you have to go with the tunnel mode. And otherwise, in normal IPSEC VPN, we always use the transport mode. We have 2 protocols, ESP or AH. After when they will exchange all these, let's suppose in phase 1, we are using main mode. Then we have a quick mode. After exchanging these 9 messages, whatever data is exchanged between your firewall 1 and firewall 2, this is a user data. Which protocol you want to use for encryption, AH or ESP? Guys, we always use ESP because ESP provides both encryption and hashing, and AH only provides hashing. There is no encryption, which means in AH there is no confidentiality, so we never use AH. We always use ESP. Okay, so guys, now let me tell you the main thing. In your what I can do, let me just guys now show you the configuration, and after that I will run some advanced debugging command in my Palo Alto Firewall, and I am going to explain you everything with regards to the main mode. Okay, because in interview they will ask, can you explain the IPSEC exchange? Can you just explain the IPSEC 9 message exchange? These are the questions they generally ask in your interview, and if you know the exchange of main mode and quick mode, you can able to crack that particular interview. So let me just go through with the configuration, and after that I'll run the advanced debug commands and we will go through with the entire process. I'm just changing here the things little bit. Okay, let me just take the access of these devices. So on this device, I got the IP address 192.168.137.11. So I'll just go here and I'll just open 192.168.137.11. In the other device, it should be, I think, 12. Yep, 12 is here. Let me log in. Admin. I have to enter the default username and password. Now I'm getting the password change required, this message. Old password is admin. New password admin add 123. Admin add 123. Click on change password. Log in again. Let's wait here. And guys, I will do the configuration of this topology from scratch, okay? Let's wait here. Meanwhile, this firewall is coming. Let me just log in on second as well. Go into device tab, setup. Configuration is guys very easy. Only you need to understand the concept, this message exchange process in your VPN. That's the main thing. Let me do all these things as well, meanwhile on secondary as well. Now you can go ahead on primary, just set the host name, firewall 01 lab.local. This is my Palo Alto firewall at head office, Asia Kolkata. Click on OK. Go to into interface. I'll configure the IP address, static one, 192.168.137.11. Let me give the IP 11 here, 255.255.255.0, 192.168.137.2. Go ahead, then let's do the commit. Go into another device. Commit is started on firewall 1. Go into firewall 2 device tab. We have to do the same thing here as well. Give the name here, Palo Alto Firewall 2. Domain name is lab.local. Asia Kolkata. This is branch office 01 firewall. Give this login banner, click on OK. Go here, interface, configure the IP details. 12, 192.168.137. Sorry, it's 255.255.255.0. Go and just do the commit. It is stuck at 98%. So what? You can just refresh. And you will get the access. Because we have changed the IP address, right? So now it will try to establish the connection with the new IP, and we have changed the time zone as well. And when we change the time zone, it will basically try to reconnect, because they will use the HTTPS connection. If time will change, now they have to establish the connection again with new time. Let's wait here. Now we have this interface and this interface. So now let me just start the configuration, like IP configuration on these interfaces. Let's wait here. It is a bit slow. Meanwhile, let me go here on my ISP. Let me do the config on this as well. Meantime, I'll take the access of my routers. F0 and F0 interface conft host name ISP01 interface F0 IP address 151.7.1 255.255.255.0 no shutdown exit interface F next is 0x1 and IP address in 170 range, right? 170. Save the config. Now we have inside head office. Okay, now finally I got the access. Sometime what you can just refresh it. It will load the things properly. And I have so many interfaces. So I will just start configuring my Ethernet 1x1 interface, which is towards ISP1. I'll go here. I'll give the name ISP01. Interface type is layer 3. Virtual router. I'll create my virtual router. VR01. Security zone I'll create, which is outside. IPv4 address 151.7.250/24. Make this interface up. Configure interface management profile, which is ping. Click on OK. Now we have another interface, which is Ethernet 1x3. This is my inside interface. Type is layer 3. VR0 and security zone is inside. Click on OK. 10.1.1.250/24. Make the interface up. Select the interface management profile. Go click on OK. Like that, we have to configure the IP address. Now go into virtual router. Delete the default one, not needed. Go here. Static route. Add one default route. DR. This is my default route. Interface is Ethernet 1x1. And IP address is next to is 151.7.1. And apart from that, I do have one more subnet on my LAN side, which is 11.1.1.0. So I need to add default route for that subnet as well. Inside 11.1.1.1. This is the series /24 Ethernet 1x3 and next to is 10.1.1.100. Because this is the IP which I am going to configure on my router. Now, if you do this thing now, you can go ahead and just do the commit. Meanwhile, let me go on my inside router. Let me just do the configuration. Host name, inside HO, interface F0x0, IP address is 10.1.1.100, 255.255.255.0, no shutdown, exit, interface loopback 11, IP address 11.1.1.100, 255.255.255.0, exit, IP route 0.0.0, 0.0.0, 10.1.1.250. I will add default route, line BTY 0 to 4, login local, exit, username Cisco, privilege 15, and password is also Cisco. This is the basic config I need to do here. Now you can see commit is going on. Let me go on my second firewall and let me just do the config. Network tab. %. Let's wait. Go here into this interface Ethernet 1x1, configure the IP address. This is towards ISP01. Interface is layer 3. You can create a virtual router. VR01. Create the security zone. Outside. 171.7.250/24. Make this interface up. Configure the interface management profile, which is ping. Now I have Ethernet 1x3 interface, which is my inside interface. And configure the IP address here, which is 20.1.1.250/24. Make the interface up and configure the interface management profile, which is ping. Click on OK. Now you can go into virtual router and we need to configure the routing. Default route towards ISP. (171.7.1). We do need to configure one more static route towards my inside network, 21st series, right? Inside 21.1.1.0-24. (20.1.1.100). Go ahead, click on OK. Let's do the commit. Go into your branch office router, conft host name, branch office 1, router, interface F0x0, IP addresses 20.1.1.100, 255.255.255.0. No shutdown. Interface loopback 21. IP addresses 21 series. 21.1.100. Exit. IP route. I will add one default route. 20.1.1.250. Line BTY 0 to 4. Login local. Let me enable the telnet on this machine. Username Cisco. Privilege 15. Password is Cisco, do right, ma'am. Commit is done here. Commit is about to complete here. So guys, till now what I have done, I have did the configuration of my lab. Means I did the configuration on this router, on this firewall, on this router, on this firewall, and on this router. Okay. I have not touched anything with regards to VPN for now. Now what I will do, I'll just take the access of both of my firewalls. I will take the CLI access for them. I'll open 11 and I open 12. Let's wait. Accept the SHS key. And sometime you will be able to see the things here. Okay, now guys, before starting the VPN configuration, what we will do, we will try to validate the connectivity from this firewall till this firewall. So what I'll do, I'll go here and I'll just issue a command called ping using the source, which is 150, 1.7.250 to host 171.7.250. Ping is working. This is the first check which you have to do before doing the VPN configuration. You have to validate the connectivity over the internet, because you know this firewall is pinging to this firewall over the internet. So if there is any problem with the connectivity, which means you will not able to form the VPN. So this is the one thing which you need to remember. Okay. And after that, once you will complete that part, what you have to do? Now we will start the VPN configuration. So any of VPN configuration, what we have to start from? ICrypto. This is the place where we will define our phase 1 policies. This is the place where we will define our encryption algorithm, hashing algorithm, everything. I'll give the name here like phase 1 policies. Here we have to define the Diffie-Hellman group, because you know IPSEC VPN uses the Diffie-Hellman asymmetric algorithm for making the symmetric keys. Okay, so what I will use here, group 5, because group 5 is the latest one. I will define group 5. I will also define group 19, group 14. These are the groups which we generally preferred. And guys, this group 1, 2, and 5, let me tell you. Regarding these 3 groups, these are the normal or general Diffie-Hellman groups. And these are the groups, the latest one. These are the advanced one, and they will use the elliptical curve algorithm. Okay, the Diffie-Hellman is it's having the entire algorithm and other things. Okay, but if you don't need to know that much details with regards to these things, define your groups. Authentication algorithm. Now we have a MD5. Authentication means these are your hashing algorithm. MD5, SHA-1, SHA-256, SHA-340, 384, or SHA-512. And guys, the relevant one which is used by the environment is your SHA-256. So I'm defining SHA-256 here as well. Encryption algorithm, we have a DES, 3 DES, AES 128, 192, 256. In environment, in organization, they are using AES 256. So I'm defining AES 256. If you want, you can define other combination as well, but not needed. If you want, you can define, because maybe when your customer is doing the configuration, because people is not having the exact knowledge about these algorithms, which one is used by the production environment, which have some type of, like we can say, vulnerabilities on them, right? So what they used to define all of them. You will see all these algorithm has been defined there, but this is not a good idea. Always use the most suitable one, which is AES 256. So that's why I'm doing. This is the lifetime for your phase one policies. This is your lifetime for phase one. Okay. Because first phase one used to come up, and after that, once phase one is up, your phase two exchange will start and it will come up. And this phase one, it has a lifetime, means after 8 hours. What they will do the renegotiation on phase one. They will just do the renegotiation again. So this is the lifetime value. I will define 8 hours. Click on OK. I'll go on my firewall 2 and I'll do the same thing, exactly same thing. Give the name phase 1. DEFI element group 5, 14, 20. You can define all of them. Authentication algorithm, I will use SAT256. I will use here 256, AES as well, and 8 hours as the lifetime. And I have defined the first part of my VPN config. This is your step 1. Define your phase 1 policies. Now you have to define your phase 2 policies, because in phase 2 also we have to define the policies again. In IPSEC VPN, we have just phase 1 exchange to secure your phase 2 exchange. Okay. So now I'll go here, I'll give the name. This is my phase 2 policies. Which protocol I am going to use? AH or ESP? I will use ESP because ESP provides us encryption and hashing both. AH only provides us the hashing. Encryption, I will use again here. I will use 256-bit CBC as a hashing algorithm. CBC, and we have a GCM. So GCM is also there, but in production environment, we are using CBC. Then I will use here SAT56 as well. Group 2 in phase 2 also we have to define the DEFI element group. So I will use group 2 here, or you can define group 19, whatever. But I am defining group 2 because if you are configuring this VPN with AWS environment, they have some limitation at their end. Okay. So I'm just going with the group 2 here. And this is the lifetime for your phase 2, which is 1 hour. Click OK. Go here and just do the same thing. You can use the default one as well if you want, but I will use my configured one. 256 CBC, SAT256, group 2, click on OK. And once you will complete that part, now we will define the IKE gateway. I'll give the name IKE gateway for head office 012, head office 2, branch office 01. Because in production environment, you will have a multiple IKE gateway. Which version you want to use for IPSEC VPN? IKE version 1 only, IKE V2 only, or IKE V2 as a preferred one, means they will start negotiation over IKE V2. If they will not complete on IKE V2, then they will fall back to IKE version 1. And guys, in production environment, people are using IKE V2. But I will use here IKE version 1 because, if you will understand the IKE version 1, you will easily understand the IKE V2 as well. I'll select here IKE version 1. Here you have to define the interface IP address. So you can define your interface and define your local IP address. And this is the public IP address, guys. Just remember. What is the peer IP address? So for peer, you can define IP address either fully qualified domain name or dynamic. If your peer having the, if you don't know the IP address of a peer at the other end, you have to go with the dynamic. And if you will go with the dynamic here, which means in that case, we will use the aggressive mode. Aggressive mode we will use if IP address is not fixed at your other end. Otherwise, we never use aggressive mode. Just remember. And define the peer address. Peer address is 171.7.250. Authentication, what you want, certificate based or pre-shared key based? I will go with the pre-shared key. And I'll configure the pre-shared key, which is admin at 123. You can configure any Cisco at 123 or any other complex one. What is the value you will use for the identification? I am going to use IP address because you know I have the fixed IP address. So I will use the identification. If the IP address is dynamic, then you have to go with the other ones like FQDN based, user FQDN based, key ID based, right? All these methods. Now you can go into the advanced. If you will enable the passive mode, in that case, this firewall is not able to initiate the IPsec connection. It will just wait, and whenever it will get the connection from other end, then only it will respond. So if you want to go with this setup, you can go with that setup. Otherwise, I will never suggest you can go with that. Enable NetT. This option we will use if you will see in this lab. Let's suppose if you will see this part of your network. Here I have this firewall. Here I have a public IP address and I have this interface where I have the private IP. Which means if I want to configure the VPN between this firewall and this firewall here, and if I want to configure this VPN, what I need to do, I need to configure the net here, static net, with the one of the public IP which is available here, with the private IP which we have to configure on Ethernet 1x4 interface. And if this is the case, in that case, what used to happen, we have to enable the NetT. Without NetT, your thing will not work. I'll enable the NetT and exchange mode. I will go with the main mode. I define my phase 1 profile here. I crypto profile, which is phase 1. Fragmentation not needed. These are enable the dead peer detection. So which means if there is no traffic on the tunnel, in that case, what used to happen, your tunnel used to go down. And if something is not happening, what these firewall they will try to do the dead peer detection. If there is any connectivity issue over the internet, so this will protect you from these issues, dead peer detection. Enable it, click on OK. Go here and just configure the IKE gateway here as well. IKE gateway between your branch office 1 with head office. IKE version 1. This is my interface and IP address is this 151.7.250. This is the peer address. Preset key is admin at 123. Admin at 123. Identification. I will use IP address because I have the static IP at both ends. Advanced. Enable NetT. Go with main mode. Define your phase 1 policies. Click on OK. Now once you will, so like we have created this phase 1 policy. This is your step 1. You've created your phase 2 policy. This is your step 2. We have created the IKE gateway. This is step 3. Now I'll move towards the step 4, which is IPsec tunnel related config. And I'll go here, I'll create the IPsec tunnel between head office to branch office 01. Tunnel interface. So I have to create one tunnel interface. I'll give the name to this interface, which is tunnel 10. This is the interface which I'm using for head office to branch office 01 site to site VPN. Go ahead, select your virtual router, go ahead and just create one zone and give this name to the zone as IPsec VPN. Give this particular name to your security zone. IPv4 address, define the address 99.99.99.1/30. If you don't want to define, this is also okay, but always just make the habit of defining this detail so we can enable the tunnel monitoring as well. If there is any issue, in that case, your tunnel used to went down. Now you can define your IPsec gateway, define your phase 2 policies. In advance, we just have a tunnel monitoring. So I will not enable the tunnel monitoring for now because I want to show you the captchas and other things. So I'll just go with normal setup for now. This proxy IDs we will use if we want to configure the IPsec site-to-site VPN between Palo Alto and Cisco ASA. Otherwise, we don't need to define, because if we are doing the VPN configuration between Palo Alto to Palo Alto, we don't need to define anything with regards to proxy IDs, because your Palo Alto to Palo Alto, it's a route-based VPN. Click on OK. Go ahead into the other firewall and just do the same thing. IPsec tunnel between branch office 01 to head office. Tunnel interface, create the tunnel interface. I will just give the same name like tunnel 10. You can define anything. This interface I'm using for IPsec site to site VPN between head office to branch office 01. Define your virtual router and define your security zone and give the detail to this zone like IPsec VPN. IPv4 address, I will use 99.99.99.2/30. Call your iGateway, call your phase 2 crypto profile. In advance, we will do nothing. Now this is the next step. So step number 1 to create phase 1 policies, step number 2 to create phase 2 policies, step number 3 to create the iGateway, step number 5 to create the IPsec tunnel settings, and step number 5, we have to define the routes now because it's a route based VPN. So I'll go here and I'll just define my routes. This is the route for branch office 01 20.0.0.0-24. This is the series, right? On my branch office. So sorry, I have to do the config first on my head office device because here I will do the routing towards my branch office through the VPN. It's 20.1.1.0/24. Interface is tunnel. The next hop is 99.99.99.2. Select this, clone it. 21st. 21st. This is the next step. Go ahead and just do this step. Here you have to define head office. And I have a 10 subnet here, 10.1.1.1. 10.1.1.0/24. Interface is this 99.99.99.1. Select, clone it. 11.1.1.0. 11. Now this is the next step. Once you will define the routing, now you have to go into your security policy and create your security policy for allowing that particular traffic. So I'll go here. I'll create a rule for IPSEC VPN between branch office 1 to head office. Source, if traffic coming from inside or IPSEC VPN, because I will allow the bi-directional traffic, guys. Otherwise I have to use, otherwise I can do one thing, maybe if traffic coming from inside. And now let me just define the inside subnet here. Or let me just define in this way. 10.1.1.0/24. 11.1.1.0/24. Traffic going towards IPSEC VPN and the destination is 20.0.0.0. Sorry, it's 20.1.1.0/24 and 21.1.1.0/24. You can define application, service, action, whatever you want. I want to allow. So this will allow the traffic from inside towards the IPSEC, but we have to allow the bi-directional traffic, right? From IPSEC to inside as well. So you can give the name like IPSEC VPN. This traffic is your inbound. This is the inbound traffic rule. If source from the IPSEC VPN and if these values is 20.1.1 and here we have a 21.1.1. Destination zone is inside and destination address is 10.1.1.0 and 11.1.1.0. This is inbound and this traffic rule I can give the name. This is for outbound traffic going out. Now go ahead and just do the commit. Now go here, configure your security policies. Configuration is, guys, very easy if you have to only stick with your concept. IPSEC VPN between head office and branch office 01. This rule I will create for outbound traffic. Outbound traffic means traffic coming from head office, right? Outbound means this traffic is going out. So inside subnet is 20.1.1.0/24. 21.1.1.0/24. Destination is IPSEC VPN. 10.1.1.0/24. 11.1.1.0/24. Action is allowed. Click on OK. Selected. clone this rule, give this name to this rule, which is inbound now. IPSEC 10 series and 11 series, because this is the series which I have on my other end. Destination is inside. Inside I have 20 and 21st. 21.1.1.0/24. Now guys, this is how we have to do the configuration. Now go ahead and just do the commit. Let's wait here. I'll go here. Let me just start the Wireshark capture on F0x0 interface. So we can able to see the captures. Just guys, give me 1 second. Okay. TLS, because I used to get this error. So let me just remove this, click on OK, click on OK. Now at least I will not get any errors. Okay. Commit is completed. Let's wait here as well for this commit to complete. And now I will initiate the IPSEC VPN. And now we will see everything. Config is very easy, guys. If you know this config, that is more than enough to work with the VPN. Now, whatever I am discussing next, which is most important and most critical. It's 98%. Let's wait. Means 99%, which means almost completed. Once this will complete, guys, just remember one thing. Now these are some advanced information, guys, which you just need to remember in your PAN-OS, and this information is only applicable for your Palo Alto operating system. In PAN-OS, in Palo Alto Firewall, in the management plane, we have a data plane, right? So in management plane, there is a daemon called IPMGR. IPSEC Manager. This is the main daemon or main process inside your Palo Alto Firewall who will take care of all the packet processing with regards to your IPSEC VPN. Means your phase 1 exchange, your phase 2 exchange is everything is carried out by this particular process, IPMGR. There is one more daemon called CryptoD. So this particular daemon is responsible for all your cryptography related tasks, your encryption, decryption. We have one more daemon called KeyMGR, Key Manager. This daemon is responsible for maintaining of your keys, calculation of the keys. Now, in your data plane, there is a daemon called MP Relay. This particular daemon is responsible for sending the traffic through the tunnel interface, and whenever it will receiving anything through the tunnel interface, This is the daemon who will basically guide towards the egress interface, MP relay. And there is a daemon called pan task. So guys, whatever packet is received by the Palo Alto Firewall, this is the daemon which is running in your Palo Alto Firewall, pan task. This daemon is responsible for the packet processing. Guys, these are the few daemons which is available in your Palo Alto Firewall and responsible for your VPN related functionalities. This pan task will do other things as well, right? Whenever any traffic is received by the Palo Alto Firewall on data interfaces, this is the daemon who will basically responsible for packet processing. Okay. So these daemons you have to remember. Now guys, in your Palo Alto Firewall, what you have to do? You have to run one command called debug IPSEC MGR or debug IPSEC global on. At the dump level, what will happen? It will enable the debugging at the dump level. This is the most advanced level. But I will not recommend in the production environment. You can try with this command. In lab environment, it is fine. Input, sorry. In production environment, you will always try running this command like gateway. You can define your gateway on at the dump level. This is the command which I will recommend. Dump, I will not recommend. You can also run at the debug level. We have some levels. Dump means this is the most advanced level debugging. You will see all the error related information logs, all the error logs, all the warning logs, all the information logs, and all the debug logs, and all the verbose logs. So this is the most advanced debugging level. Then we have a debug. This is the less advanced in comparison to the dump level. So maybe you can try with debug. Then we have a normal, error, and warn. These are the basics one. The most lower one is your error one. And after that we have a warning. And after that we have a normal, then debug, then dump. These are the daemon. These are the debugging levels. So what? Let me just run at the dump level. Debug IPSEC gateway. Then IPSEC gateway, define your gateway and run at the dump level. You can go here, press the question mark, tunnel, define your tunnel on and run here as well at the dump level. And after that, run this command tail follow yes mplog ikmgr.log. This will show you all the live logs. On my another firewall, I'll go here, I'll run the debug IPSEC global on at the dump level. Tail follow yes mplog mplog ikmgr.log, because this is the main daemon who is responsible for everything. Now I'll do one thing. Now I'll go here. You can see I don't have anything on my Wireshark capture for now. I'll go here into my branch, inside branch router. And let me just initiate some traffic from this particular router. I'll go here. I'll just do the ping to 10.1.1.100. Now you can see we have seen the 9 message exchange, and after that you can see some ESP packets, right? There are 2 ping is succeeded. Now let me take the telnet of my this router, head office, Cisco. I have entered the wrong password. Cisco and Cisco. You can see everything is encapsulated inside the ESP protocol. So version, now you can run whatever command you want to run here. So running config, we have run all of them, right? And I'm fetching this detail of my head office branch open. Now let me just exit out. I'll go here. I'll stop my captures. I'll go here. I'll just type Control C. I'll go here and I'll just type Control C. I'll disable the debugging. Off. I'll go here and I will also disable here as well. And I'll just leave it as a normal level. Now let's try to understand the things, guys. I'll go here on the top and we will try to see everything. How the VPN is implemented inside your Palo Alto. And if you able to understand this part, even though your troubleshooting become very easy, guys. Now you can see your negotiation has been started from here. Now let me go on top and your phase 1 negotiation is started from here, right? Okay, cool. Now let me do one more thing. Let me just go here. And you can see from here they have started the negotiation. Message number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. These are your main mode messages. And after that, we have a 3 messages in quick mode. So these are your 9 messages, guys, right? In actual. Now let's try to understand all of them. This is my message number 1. And you can see, guys, just remember one thing. This message number 1 have the details of your source IP address. This is the IP address of your branch office route firewall. And this is the IP address of your head office firewall. And inside this head office, we have a UDP protocol and port number is 500, which means your IPSEC 9 message exchange is happening on UDP 500. Just remember. And guys, if there is any net device in between, that time they from message number 5 onwards, they will change the exchange process on UDP message number 4500 in case of net traversal. Okay. Otherwise, they will do the communication over UDP port number 500. And this is the actual data which are available in your message number 1. Now in production environment, what they are going to ask, or in your interview, they are going to ask, can you explain the 9 message exchange process of the IPSEC VPN? So now let's try to understand that process in detail. Okay. So guys, what used to happen, if you will know, my firewall 1, he has just started the IPSEC connection, right? So we have got the message, which is the first message from firewall 2 towards firewall 1. This message known as main mode message number 1. Okay, this is the main mode message number 1. Now in this main mode message number 1, what is the details available in your first message? So in your first message, it has the detailed call initiator cookie. So this is the first information which is available into this message, which is initiator cookie, is also known as CI value. It has a detail of your header. It has a detail of your haggle. What is this haggle? Haggle is your phase 1 policies. Haggle may, in haggle, like we have a H, which is your hashing algorithm. A means your authentication method. Which authentication method we want to use? Reset key, or we want to use certificate, which is PKI. Then we have a G. G stand for Diffie-Hellman group. DH group. L stand for lifetime. What is the lifetime for phase 1? And E stand for encryption method or encryption algorithm. So it has the CI value, which is initiator cookie. It has your Haggle information, which is your phase 1 policies. It has a net T and vendor ID. Net T means it will basically put the net T payload. Net T detail means firewall 2. Tell this firewall 1, I am this net T is enabled at my end. I'm supporting net T. And it will put the vendor ID. Vendor ID means it will put the details of vendor means firewall 1. It's a Palo Alto. So it will put vendor ID as a PAN OS. So this is the detail is basically they used to exchange in your message number 1. Now this initiator cookie, guys, how they will calculate? This cookie is calculated on the basis of source IP address, destination IP address means source IP address means IP address of the public IP address of your firewall 2. Public IP address of your firewall 1 means source IP, destination IP, random number, time and date. Because guys, there's a one random number is available on both the PAN OS when they start the IPsec exchange process. And your cookie is a 8-byte pseudo random number. The size of your cookie is 8 byte. And we will use this particular cookie for anti-clogging purpose. This is the main purpose of your cookies. Time date. So guys, it's just a MD5 hash of source IP, destination IP, random number, time and date. And cookie, it will protect against the replay attack. If someone is trying to, let's suppose what somebody is doing, one hacker he's doing, he's sending the message number 1 multiple times towards your device. Multiple message number, main mode message number 1 you are getting. Or maybe he has sent the message number 1 and now he is trying to send message number, or maybe towards other end he's sending message number 2, like that. Towards other end, maybe hacker is sending message number 2 because he will wait for message number 2. It's a DDoS type of attack, right? It's a message coming from hacker, and how it will protect? So they will protect with the help of cookies. Now let's try to understand this is the correct information or not, right? Whatever information I have written here, is this correct or not? So let's try to validate this information. So I have captured the message number 1. Now how you will make sure the captured packet is the correct one? So you have to go to inside the UDP and you can just check the size. UDP payload size is 276. Now you can go to into your logs and your firewall 2. And what you can see here, they did the phase 1 negotiation is started as an initiator because this device is an initiator in main mode. Initiated from this device. So this is the IP address. This is the port number towards the firewall 1 on head office. This is the port number. This is the cookie. This is the initiator cookie, guys, CI value. And your responder cookie CR value is 0. Because CR is not calculated yet. CR is calculated by the responder, the firewall 1, the head office firewall. And what they have done, they have created the payload. They have created the payload for your phase 1 policies, NetT payload, and they have created the vendor ID payload. And they have just sent a 276 byte of message from firewall, from branch of his firewall towards the head of his firewall. using the 260 byte message will be sent over the socket number 1024, and this is the actual data on that particular packet. And once they will send, now here just change the phase 1 state has been changed from 1 to 3, means now it will send the message number 3rd. Now let's try to understand. This is the correct message, right? If we will check the size, this is the correct size, which means we are looking the correct packet. And even though if you will go here into your phase 1, here you can see phase 1 negotiation has been started. But before that, you will see one more thing here. This started as a responder in main mode. This is the cookie value from initiator, and this is the responder cookie, which is calculated by your head office firewall. And it has just started the packet processing. It has started the packet processing. It has received the vendor ID according to this RFC, and it will check that vendor detail. DPD, dead peer detection is supported or not. See, received vendor ID is PAN-OS, the next generation firewall. He will get the vendor ID detail. Remote is also PAN-OS. NetT selected version is this, means there is a NetT support available is there on the other end. Like that, it has just start processing these particular packet. This is the message number 1. Now let's try to understand from here. In Wireshark captures, I'll go here and I'll just open this part. You can see we have a initiator cookie. This SPI is your cookie. You can think about this is a CI number, because SPI is something else in your Palo Alto Firewall, in your IPSEC VPN, and SPI comes in your phase 2. So you can think this is just a cookie value, CI and CR. Security association payload. Now you will get the other details here. This is the version. We are using IKE version 1. Identity protection main mode. Go here, and this is the security association payload. You check the payload information. Now see, he's sending the lifetime detail 28800 in second, which is your 8 hours. So they will exchange the seconds and they will exchange the lifetime in seconds. We have defined in hours, but they will exchange in seconds. This is the algorithm which we have defined in your phase 1, AES CBC 256. We have defined the authentication method, which is pre-shared key, hashing algorithm, which is SHA-256, and Diffie-Hellman group. This is the group 1536. This is your DH group 5. This is the size of your keys in group 5. You can see Diffie-Hellman group 5. And guys, if you remember, if you have seen one more thing here, if I'll go on my network tab, on my iCrypto, in phase 1, you can see here I have defined 3 groups, which means what my firewall 2 will do, he will send 3 combination of your phase 1 policies. Like in one combination, it will use this as an authentication method, this as a encryption method, this as a lifetime, and this as a group. In next one, it will use this, and group 14 as a next combination. So right now, because here only 3 combination is possible, so it will send all the combinations. If you will add here one more group, let's suppose you have defined this. Now, how many combination? Now you will see multiple combination is possible, like one with this, and this. Another one like this, and this, right? So whatever combination is possible, they will exchange all the combinations here. Sometime you will see the size of your message number 1 is around huge, maybe 100 plus bytes. Sometimes when you will choose multiple combinations here, because I have just configured the things very limited. Now you can go here, and even though you can able to see the things. Now we have a payload number 2 because you know these are the three in this is the information which I have got. I have a wait. This is the combination, first combination, right? 1, 2, 3. These are the three combination. You can see here we have everything is similar. Only the group is 2048, which means this is your group 14. Then we have a next one where also see lifetime is same, encryption algo is same, authentication method is same, hashing is also same, but this time group is 20, which is a random ECP group, elliptical curve group basically. Then we have a net traversal related information here. These are the vendor ID details. So this is the payload information which are available in your message number 1. And then we have a dead peer detection information, right? So if I'll go here, vendor ID, and apart from that, we do have a DPD information. So guys, this is the information which are available in the message number 1. Now, once my firewall 1 receive this message number 1, what it will do? It will basically start processing this message number 1, and you can able to see this particular processing. It has just begin the processing. It will get the details of NetT payload. It has just start the comparison as well. What it will do now, whatever phase 1 policies I have received from firewall 2 on firewall 1, now firewall 1 will also have these phase 1 policies. Now what it will compare both the policies, and it will basically, if the match is happening, what it will do, it will agree on that match. So it will do the comparison. You can able to see all these things here. See, it is matching the lifetime details. This is the third number proposal, right? Like proposal number 1. And after that, you can see it has just did the comparison between the peer policies, and they have agreed on lifetime, which is 8 hours. Encryption method, they have agreed on AES 256. Hashing method, they have agreed on SHA-256. Authentication method, they have used pre-shared key, and the DS group, they are using DH5. And you can see an acceptable proposal found. Now let's tell me one thing. Let's suppose whatever phase 1 policies combination we are receiving from firewall 2 towards firewall 1. If on firewall 1, we don't have any matching, means we have a different set here and we have an altogether different set here. In that case, what will happen? Your IPSEC VPN exchange will stuck at this particular point of time in message number 1 itself. And you will get the message here. There is no matching proposal. Okay. Now you can see once match is happening, now it has just changed the phase 1 exchange from 1 to 2. Message number 1 to message number 2. Now it is also adding the payload detail. And it has sent one packet of 140 bytes towards your firewall 2. Now guys, the first message which we have received from firewall 1 is 370 sorry, 376 bytes. But you can see packet size is very small here, 144 bytes. Why? Because whatever phase 1 policy he has accepted, he is only going to send that particular combination. Firewall 1 will not send all the combination. Just remember. Okay. And you will see it has just sent this packet. And after that, you will see here, we have received one packet of 140 bytes from 151.7.250 from firewall 1. This is the data on that packet. Now what, it will start processing this packet. See, begin the processing. It has seen three things here, like it has a security association payload and some vendor ID related and other details like your NetT payload and other thing. So they have received the vendor ID and DPD support. They got the vendor ID PAN-OS. NetT is there. Just give me 1 minute, guys. Okay. Now you can see it has just begun the processing. It will just compare the, it will also do the comparison, guys, with regards to the phase 1 policies. And you can see compare has been done and they have agreed on these ones and acceptable proposal found. That's how they will basically complete the message number 1 exchange and message number 2 exchange. Now this message number 2 have some information which includes your initiator cookie, and here it will add the responder cookie as well, CR. You will see the Haggle information from the responder. This is the Haggle information from the initiator. Then we have a NetT detail, vendor ID detail, and DPD detail, that peer detection. This is the information available in the message number 2. And guys, this message number 1 and 2, they are exchanging over the clear text. You can able to see the information. This is your message number 2. If you will see, this is the correct message. We have a correct size here. This message they've exchanged on UDP 500 packet, 500 port. And you can check the details here. Initiator cookie and responder cookie is there. We are using version 1. These are the flags. This is the security association payload information. And right now, if you will check here, we just have one payload, one combination. Only one combination is there. Lifetime, encryption algorithm, hashing authentication method, hashing algorithm, DEFI element group 5. Now NetT support is there. That peer detection is enabled. This is the only payload which they have exchanged in message number 2. Once they will complete the exchange of message number 2, now this firewall 2, what it will do, it will process this message number 2. We have seen the processing. And after that, what it will start the message number 3. It will basically send one message number 3. Now let's try to understand what is the information available in the message number 3. And this is the most critical information, guys. If you will understand this detail, well and good. Always remember CI and CR combined and used for session identification, protect from the session hijacking attack. SAI, which is your security association or your Haggle information from initiator or your phase 1 policies from initiator. SAR means this is the security association from responder or your Haggle information or your phase 1 policies from responder. Should be matched on both the side. If there is a mismatch, then you will get an error message on the debug like attribute is not acceptable. This particular message you will get. Now let's try to understand message number 3. You will see CI/CR value, and they will basically also do the calculation of public key. They will also send the nonce value NI, which is a public prime number or pseudo random number. In message number 3, what you will see CI value, CR value, and I can say X, which is a calculated public key. And you will get the nonce value, which is NI. This is the information which is sent by on message number 3. Now we have a message number 4. Here also you have a CI value, CR value, and let's suppose calculated public key by the firewall 1, which is Y, and you will get the nonce value, which is NR. Nonce from the responder. Nonce is just nothing. They are just a public prime numbers or pseudo random numbers. It's a combination of public prime numbers. They will use these nonce value in the calculation purpose. And guys, this message number 3 and 4 exchange is known as a Diffie-Hellman exchange. And guys, this exchange process is the core of your IPSEC side-to-side VPN. Now let's try to understand the details of these messages. So what they used to do, they will calculate the public key. How they will calculate the public key? So guys, in your IPSEC VPN, there is a concept of, there are two variables we will be having. We have a variable called G and we have a variable called P. Variable called G and variable called P. These variables is available and the value of these variables is G equals to 5 and P equals to 17. And guys, these values is fixed in IPSEC VPN. In actual, these value is bit complex, but I'm just taking a number here like 5 and 17. These are the values of G and P. And after that, what this X, they will calculate by using this formula. Private key. So they will use the formula called G private key mod P. This is the formula they are going to use. So if I will go here, if I'll write down the value of X equals to G raised to the power private key. So if I'll go here, if I write down here private key, then mod P. This Y value they will also calculate in similar way. G raised to the power private key, then mod P. And guys, as I have told you, firewall 1, it has a combination of, it has a public key and it has a private key. Your firewall 2 will also have a public key and it also have a private key. These keys is available and they can able to generate. If you heard the command called crypto key generate RSA, right? They will use these type of commands to generate this public key and private key combination. And there is a daemon called crypto D who is responsible for doing all of them. So let's suppose public key at firewall 1 is, let's suppose 5, and private key at firewall 1, let's suppose 6. I'm taking these hypothetical numbers. And always remember guys, first private key we will generate, and using this private key we will generate the public key. So public key we generally derive from the private key only. Let's suppose the value is 4 here and 8 here. Like these are the individual values. They can use anything. In actual, here you will get a very big numbers, or it's a combination of characters like that. But here I'm taking these hypothetical numbers just to show you the calculations. Okay, now what they will do? Now they will calculate the value of this X. So let's do the calculation for X. What is the X value come here? So I'll just open my calculator on my PC. Now let's try to calculate the value of X. So G is 5. Then we have a power of private key which is 8. So you can see, you can go here, use this 8 equals to this value. Now we will have a mod P. You can use the mod, which is 17. And the calculated value is 16. This is the final value, right? Now let's calculate the value of Y as well. You can go here. Calculate the value of Y. G equals to 5 raised to the power private key, which is 6. This is the value, then mod 17, because 17 is fixed. So the value came, which is 2. So the value of Y is 2 here. So now, instead of this X, they have exchanged 16. In Y, they have exchanged 2. Now, what they will do after that? After that, once they will calculate this particular values, calculated public key. What they will do now, they will basically now the session key creation is started. Once they have these values, once they have calculated these values and they have exchanged with each other, now the actual formula will start. Now what the most important part, which is DH key they will create, which is also known as Diffie-Hellman key. And Diffie-Hellman key equals to calculated public key raised to the power private key mod P. This is the formula for DH key. Calculated public key raised to the private key mod P. So if I will go here, if I will type here DH key, this is the main key, guys. Diffie-Hellman key equals to, if I'll say calculated public key, calculated public key, which is this X raised to the power private key, which is this one. Then mod, what's the dat in mod? Mod P. Same thing here. DH key equals to calculated public key, which is Y. Then they will use the private key here. Then mod P. Because guys, now, because they have exchanged, they have calculated this value of X here and Y here, and they have exchanged these values. If anyone able to know these values, he will not get this value of this one, this key. Private key is not they are going to get, because they are not exchanging these values. And they are just using here Diffie-Hellman algorithm or Diffie-Hellman formula to do the calculation. Now, if I'll say this DH key, if I will calculate this DH key value here and DH key value here, these value will be similar. And that's how they will calculate the similar key. Now let's try to do the calculation. So here, what is the value of X? Value of X is 16. 16 raised to the power private key, which is 6. Then we have a mod P, mod 17. And the value is coming, which is 1. Now let's do the calculation into the other end. And guys, this is the actual calculation is happening in your IPSEC VPN. So let's go here. Let's do the calculation. Y, value of Y is 2. 2 raised to the power 8. This is the private key. Then mod 17. You can see the value is 1 here. Now you can see, guys, now they have created the same DH key, even though they have not exchanged the private keys. Without exchanging the private key, they have calculated the DH key, which is similar. And once this DH key is calculated, they have calculated, because see, this key is similar at both ends. And after that, they will start the rest of the keys calculation. Now let's try to understand the rest of the key calculation. So I'll go here. And how they will do the calculation? So they will use this particular formula for that. Just give me 1 second. Let me decrease the size for this. I'm just putting this here, okay? Now what they will do? Now, once they have this DH key, now what they will do? Now they will first generate the ASCII ID. Here they will generate ASCII ID. And here also they will generate the ASCII ID. And they will use the HMAC. They will use here your preset key, because we have configured the preset key admin at 123 here and admin at 123 here. So now they are using the preset key. They are using this nonce value NI and NR. Then they have exchanged this NI value and NR value. And they will just calculate the ASCII ID, and this value is similar here and this value is similar here. And after that, they will calculate the ASCII D. This is a derivative key. Now, for calculating this ASCII D, they will use HMAC algorithm. They will use this ASCII ID, whatever value we have get here, as a key, and they will use DH key, CICR, and 0 as a data. On this data, they will basically run the HMAC using this key, and whatever value will come here, this key is known as ASCII D, which is a derivative key. And after that, they will calculate the ASCII A, which is a authentication key. They will use ASCII this as a key, and ASCII whatever we have derived here, DH key, CICR, and 1 as a data. This they will consider as a data, and this they will consider as a key, and they will calculate. And after that, they will calculate ASCII E. E they use for the encryption purpose. A they just use for the hashing purpose. And that's how, guys, they will do the calculation for these particular keys. These are the Diffie-Hellman keys, and these keys is similar on both end basically. In both of these and these keys is similar, guys. In both the devices, these calculation is similar. So guys, because you know now, till message number 3 and 4, these messages they will also exchange in a clear text. Now, because you know, after exchanging this message number 3 and 4, now they have calculated the ASCII A and ASCII E. Now they will use this E for encryption purpose and A for hashing purpose. Now, whatever communication they are going to do, everything is encrypted. You will not able to see. So now let's try to see the information of message number 3 and 4. I'll go here. I'll open message number 3. We have an initiator cookie, responder cookie, key exchange. You can see next payload is key exchange. This is the version detail, flag detail. Now you can see key exchange payload. Now guys, this is the calculated public key, which is, I can say this is your X value according to our whiteboard. This is the X value. They've calculated this value and they have exchanged. This is the nonce value. This is your nonce payload. Apart from that, guys, they will also introduce a 2 more payload, netd. I have not written this payload here. One more information is available, which is netd here. Netd. Here they will exchange as netd means they will just exchange netd packets. Just they will tell each other they have a support for netd. Now in actual netted detection they will do in message number 3 and 4. So they will exchange netd payload. What is this netd payload? If I will tell you, so what they used to do, they will take the source IP address like 170.1.7.250 and port number. They will take the destination IP address 151.7.250 and port number. And what they will do, they will create a source socket payload and destination socket payload. IP with port number is known as socket. And what they will do, they will action this particular payload in hashed form. Okay, they will action this payload in hashed form. This device, he will also do the same thing. He will also action this payload. If there is any net device, that time this payload match will not, there is a mismatch with that particular payload basically during that time. So that's how they will detect the net guys in your IPsec VPN. So now you can see they have this particular payload, right? netd, this is the payload. This is the nonce detail. Now let's try to see this particular packet here. Now you can see, now he has sent one more packet. This he has added the remote and local netd payload, right? And if you will see here, he has just compute the DH private key. He has created a DH public key. This is the value of X which he has created. You can see the value is starting with D5V. And if you will see here, this is the same value D5V. This is the calculated public key, guys. Or you can say calculated DH key. We were here, right? And after that, they will send this particular message of 360 byte towards my firewall one. Now I'll go on my firewall one and you will see I will receive this particular message. Page one is there. Just go on top little bit. See, we have received, this is the send, this message he has sent. So receive message we are not getting somehow, guys, because you know, here I have not run the debug at the dump level, at the global level, right? So I'm not getting, but you can see he has start processing the packet from here. Hashing on this netd, there he is doing the netd verification and netd payload is matching. So net not detected. He has changed the message exchange from 3 to 5. Now what you will see here, he has just processed the things. See, 316 bytes from this device. He has added the packet. Now preset key found. Preset key, this is the preset key in your encoded form. He has a combination of nonce 1 and nonce 2. This is the nonce value it will get. And after that, what? Now he just start the calculation of ASCII ID, which I have told you. And this is the ASCII ID which he has just calculated. Now, if you want to see the same thing here, let's try to understand the same detail here as well. We have received one more packet from this machine. This is the packet payload. And now he has just done, he has checked everything. netd is, all these verification is done. Now you can see he has computed the DH shared secret. This is your DH shared secret, guys. Preset key found. This is the preset key. None has been found and they have just calculated the ASCII ID. This is your ASCII ID. But before that, let me go top again. Because guys, this is the main thing. You can able to validate entire calculations here. And I'll just go through with that process. This is the key which they have calculated like DH shared secret. This is the similar secret is created here and here as well at the other end as well. This is the same value. And once they have this value, they will basically do the calculation for ASCII ID. Here we are not able to see the all the messages, guys, because some message has been not available because we have not run the debug at the global level. Okay. Now you can see he is calculate ASCII ID. Once they will calculate this part, this value, and I'm talking about this value, guys, this. Once they will calculate this, now they will calculate this ASCII ID. And this value is will also same at both the end. And this value they will calculate if you will see with the help of preset key none's value. That's why he has basically get the preset key. He get the none's value and they have calculated the ASCII ID. This is the one. It's starting from BBA and ending with DD1. Go here, you can check the same thing. Preset key nones and he has calculated this key. This is also similar. It's starting with BBA and ending with DD1. And after that, I've told you they will calculate the ASCII ID. And for that, they are using HMAC SHA-256. And this is the ASCII ID derivative key which they have created. Starting with 128, ending with E0C. And you can see E0C, same key. Then ASCII ID A for hashing purpose, ending with B71. And now you can see B71, ASCII ID A, then ASCII ID E. CB4. And here you will able to see the same thing. CB4, right? Now they are able to calculate the same keys, guys. And after that, they will basically do the final encryption key computation. This is the final encryption key which they have calculated. Final encryption key. And now you can see phase 1 state has been changed from message number 5 to 6. And after that, you will see here, once they will calculate this detail, now what? Now they will start calculating the identity payload and other things. They will do the identity payload calculation. And they will send one more message, which is a 92 bytes. Now this message is encrypted, you can see. So your phase 1 exchange, in phase 1 exchange, encryption will start from message number 5 onwards. Now guys, you will get the next message from here, which is your message number 5. And this device will send the next message, which is message number 6. Now these are the encrypted messages. So in this message number 5, you just have a details of CICR, IDR, and hash I. So let me write down this detail. CICR, identity payload from initiator, and hash I payload from the initiator. CICR, identity payload from the responder, and hash R, like hashed payload from the responder. Now, if you want to see the detail, how they will calculate this IDI, this is just an identity payload. This is just an identity payload. And what they used to do to calculate this identity payload, they will just take the source IP address here and the destination IP address here, and they just do the hashing by using the authentication algorithm, this SKIDA. And after that, they will generate the hash like hash I and hash R by hashing the X, Y, CI, CR, SAR, and IDR. All these values they will use to generate the hash. That's how what they used to do. They will basically do the calculation of your message number 5 payload and message number 6 payload. And guys, just remember one thing. Whatever preset key we have configured, they never exchange this preset key. Only we are using this preset key in the calculation of your SKID, this particular key. Only we are using this preset key in the calculation purpose here. When we have generated this SKID, that time only we are using this preset key. Okay. We never exchange the preset key. And if there is a mismatch in your preset key, you will get the sanity check failed or your preset key malformed, this type of messages in your debugging. Now, once they will basically calculate these payload. Now, if you will go here in your Wireshark capture, you will not able to see anything. In this message number 1, 2, 3, 4, if I'll go into 5, you will not able to see anything. You have CICR value and everything is encrypted. See encrypted data. You will not able to see anything. Message number 5 also, 6 also, you will not able to see anything. Now let's try to decrypt these particular messages to just check the data, because we have the key, so we can able to apply the decryption. Go to into preference, protocol, just type here, ISACamp, IC version 1, go here. I have so many data. Let me just delete the data. So what you have to just define the initiator cookie and encryption key. So what you can do, this is the device who is the initiator, right? So I'll go at the starting and I'll just copy the initiator cookie, which is this one. I'll go here and I'll put this value and encryption key. Now you have to put the encryption key. This encryption keyword, you have to put this particular key. You can go down. Final encryption key is computed, which is this one. Go and just copy and just put this value. Click on OK. Click on OK. Now go here. Now whatever data previously you have seen as encrypted, now we can able to decrypt it. So guys, that's how we will decrypt the IPSEC messages in your Palo Alto Firewall, because we know the keys and they are using the same keys for doing all the things. Now what you have a identity payload here, right? IDR, and in identity payload, they are just putting the IP address. You can see 151.7.250. And after that, you have a hashed payload. This is the hash detail. That's it. Go into the next message, this one. You will see the details. We have the identity payload and we have the hashed payload. That's it. And this message number 5 and 6, they are just using for the authentication purpose, because as I have told you, they are using this preset key just for the authentication purpose. How we will make sure we have configured the correct preset key at both ends, at firewall 1 and firewall 2. So what they used to do, they used to create a IDI payload and IDR payload. They will also calculate the hash I payload and hash R payload. And what they used to do, they will just in IDR payload, they will just put the IP address, like 171.7.250. This data in hash I payload, what they will calculate, they will take X, Y, nonce values, SAI values, SAR values, all these values they are taking, like I have mentioned here. X, Y, CI, CR, SAI, and IDR. And instead of nuns, it's like CI and CR. X, Y, CI, CR, SAI, and IDI. They will calculate, they will use these values to calculate this hash I values. And guys, if there is any problem, let's suppose if there is any problem, if we have configured the wrong preset key, what will happen? This particular payload will not match, right? This payload will not match. The other end payload will not match because other end is not able to decrypt it properly. If it is not able to decrypt, if it is not able to do the hashing, which means he is not able to do the validation. If there is a mismatch with regards to preset key, because if there is a mismatch with preset key, whatever keys you have calculated for hashing purpose and for encryption purpose, these key value will change. If these value will change, then other end will not able to not having the same keys, means he will not able to decrypt this message or not able to hash this message. So that's how the hash validation will fail, and that's how they will basically do the validation with regards to the, or that's how they will basically do the authentication validation with the help of preset key or PKI. Okay. And after that, guys, once your phase 1 exchange is completed here, what used to happen after that? In your Palo Alto firewall or any other firewall, there is one assay called IPSEC assay is created, or your phase 1 is in up state, and this is just a bidirectional assay. There is only one assay which is known as IPSEC assay, and it's a bidirectional assay. And the lifetime for this assay is 8 hours. Just remember. And once they will complete this particular part, what they will move further towards the phase 2 exchange. Now they will do the phase 2 exchange. In phase 2 exchange, what? They will exchange message number, quick mode message number 1. Then here from here you will get the quick mode message number 2. Then from here you will see the quick mode message number 3. Now in this 3 message, what you will see? If I'll go here in the quick mode, we have the nunch value again. They will exchange some different nunch value. They will exchange the phase 1 policies, which is also known as, they will exchange phase 2 policy, which is known as proposals. Then transform set, which method they want to use. You want to use for phase 2, like tunnel mode or transport mode. You will also exchange X dash, another calculated public key, and the proxy IDs if you have configured. But guys, just remember one thing, this X dash or this NI dash, you will only exchange if you have enabled the perfect forward secrecy, PFS, in your phase 2. If you enable the PFS in phase 2, what will happen? PFS will enforce the firewall to do the renegotiation of DH exchange again in the phase 2 to do the calculation of new keys. Now they will derive the new keys again. Whatever keys we have derived in your phase 1, we have just derived to secure the further communication of phase 2. Now in phase 2, they will derive the actual keys which they will use for calculation, for the data encryption and hashing. You can see if PFS is disabled, then X dash or Y dash is not exchanged. If PFS is enabled, then X dash Y dash are exchanged. Also, they will use ASCII ID for creating the new session keys. And they will create 3 keys which are ASCII ID, ASCII ID A, and E again. Okay. So that's how they will basically do the exchange for quick mode. And if you go here, this is the quick mode message number 1, and you can validate the details. Version detail, flag detail, everything is encrypted, but somehow we have decrypted it. They have exchanged some hash data. This is the hash data, right? Then you can see security association payload, where you will get the proposal. We are using ESP as a protocol, and we are using lifetime as a 1 hour, which is 3600 seconds. We are using encapsulation mode, which is tunnel. Key is 256. And we are using SAT256 as a key here. And we are using Diffie-Hellman group 2 as a PFS. So if we will configure the DH group, which means we are enabling the perfect forward secrecy. This is your authentication method. This is your key length, tunnel mode, and you will get all the details. If you will configure more combination, you will get more data. Then we have a nonce payload again. Then we have a key exchange payload. This is the X dash, I can say. Then this is your proxy ID 00 right now, all zeros. Payload identification and identification data, all zero. This is your proxy ID's information. Then we have a next message, where if I will explain from starting, you have the payload information. We are using IPSEC. This is your lifetime detail, tunnel mode, encryption key length, hashing key, Diffie-Hellman group 2 for PFS, nonce value. This is N dash, you can say. NR dash, right? This is your Y dash, you can say. This is the key. And this is your proxy IDs. And this is just a acknowledgement message, guys, the last one. Just the acknowledgement message. And that's how they will basically do the IPSEC VPN exchange process. And if you want to see the detail here, you can see your phase 1 negotiation has been succeeded. Now your phase 2 negotiation is started. And this is your actual payload of your message number 6. You can see they will calculate the hash, they will check the details, right? Everything. And after that, your negotiation will start on phase 2. See, compute the details, you can see. Calculate DH public key. This is the value which the DH private key, right? Then compute DH public key. This is your X dash, this which they have created. Proxy ID related information. So they will do the calculation for everything. Now he has sent the message packet towards the other end, right? From other end, he has received this particular, this is the packet. We have received the packet from firewall 1. This is the size. Now it will do the things again, right? It will calculate everything, check everything, right? See, it is received the proposal. It will it will match, like it will just check for the matching phase 2 policies. We have found the match, right? So you will get this message. We found the match with regards to encryption algorithm and hashing algorithm. Single, peer single bundle, right? All that detail. And after that, it will do the calculation for your keys again. This is the key mat calculation. Another thing, key mat means key material. Key mat compute. And finally, he has just derived the things, and your phase 2 negotiation is completed. successfully. And after that, you will see whatever messages now you will have here, ESP, they all are encrypted. You will not able to see anything here. But because we know the keys on Palo Alto. If you go here, this is the keys, right? They have the final keys which they are using for data encryption, which is this one. Auth key they will use for hashing purpose, and N key they use for the encryption purpose. Now, if I will use these keys, I can able to decrypt the ESP packets as well. Now let's do that. This is the source IP. This is the destination IP. So now you can go into your Wireshark. Right now you can see in this ESP, I'm not able to see anything. So I'll go here on edit, preference, into this protocol section, and I'll type ESP. I'll go here ESP essays, because these keys is already there from my last session. So what you have to do, only you just need to do one small thing here. You can just add your details. I'm not removing anything. I will define my source IP address is 171.7.250. Firewall 2 IP address, then firewall 1 IP address. Now I have to define the initiator SPI number. I have to define the SPI number in and SPI out. So you can go here and let me just check the final details. So this is the final asset database. This is the SPI in. So I'll just copy this SPI value. Asset source is this, asset destination is this. And asset source is this, asset destination is this. So I have to keep this particular SPI number. I'll go here and I'll just add this SPI value. Encryption key, I will use AES CBC because I was using AES CBC 256, so I will use the same. And even though you can get the details here as well, AES 256, right? And after that, you have to define your encryption key. And your encryption key is this one. You can copy till here, go here, and just add 0x, and after that, copy the value. You have to use the hashing key. Hashing key is 256, 128, RFC 4668. This is the one. Now we have to copy the authentication key, and this is your authentication key. Go here, copy and put. I will delete this one. I'll delete this one as well, previous data. Now let me just add the details again. Now 151.7.250, because if I'll just, let me just show you something. If I'll just go with this, even though I'm not getting the save option here with that information only. (151.7.250), 171.7.250. And now you can just look for this one. This is the source, this is the destination, and this is the SPI number. Define your encryption key, AES CBC, RFC this. Now you have to type your encryption key here. And your encryption key value is this one. In key is this. Go ahead and put this value 0x, Control V. Guys, you have to make sure there's no space, because here one space is added. So I have to remove this space. From here also I have to remove this space. That's why I'm getting this message here now. HMAC, And after that, just copy your authentication key, which is this one. And key is exactly same. Zero X, Control V. Control save it. Save it. Now you can see we have the instead of ESP. Now you can see this is your ESP payload. Inside this ESP, we have the actual IPv4 header, and behind this, we have the actual internet protocol header. Then we have some telnet messages, right? All they are inside the ESP. Now because we have decrypted these messages, so we can able to see anything. If you will follow the TCP stream for telnet, you will get everything. This is the one which I have run initially, right? You can see anything now. See? So guys, this is how your IPSEC VPN works in the Palo Alto Firewall. And that's how basically we can able to do the decryption of the packets in your Palo Alto Firewall. And guys, this is all about with regards which you guys wants to know with regards to the IPSEC VPN in the Palo Alto Firewall. So we have seen the configuration. We have seen the actual exchange process. We have seen the decryption. And if you have that much knowledge, you can able to troubleshoot any issue, because I have shown here the working behavior, right? Now, if you will just configure a mismatch, what you have to do, if you want to really learn a few more things regarding this IPsec and Palo Alto, now what you can just do just configure different phase 1 policies here, and just try to initiate the VPN connection and check your logs. What is the error message you are getting? So that's how basically you can just configure the wrong preset key here, wrong preset key here. Check the things. Try to take the capture of your VPN packet using Wireshark and try to analyze them. Try to apply the decryption and try to see what's going on there in a backend. Validate the message of this IKE version, this IKE MGR daemon. If you want to see, there's a few other daemon as I have told you, like your key MGR. You can also validate the logs of these particular daemons. Okay. So guys, this is all about with regards to the IPsec site-to-site VPN.